Alrighty, here's the dividing polynomials worksheet. If you missed class, hopefully this is helpful, and if you didn't miss class and it's still confusing, hopefully this is helpful also. I'm just going to go over the steps for some of them and do a couple of examples, and hopefully it'll make sense. If it doesn't make sense by the first one, hopefully it will by the second or third or fourth or seventh one. So, alright, let's get going. So, when we divide exponent or polynomials, it's pretty much the same as dividing normal numbers, just with a couple tweaks. So I'm going to set up like a normal division problem, and then I'm going to say what times m is going to give me m squared. And I know that m times m is going to give me m squared. So m times m is m squared. And then I go m times 8, negative 8 is negative 8m. I'm going to subtract those. These are going to cancel out. Negative 7m minus a negative 8m is going to give me a positive m. I'm going to then drop this down. So my new equation, my new polynomial is m minus 11. So then I'm going to say what times m, back up here, is going to give us m. And I'm going to say 1. 1 times m is going to give me m. 1 times 8 is going to give me negative 8. When I subtract that, those are going to cancel out, and I'm going to be left with negative 3. So just like in normal division, if we say 11 divided by 3, and we say it goes in 3 times, and then we have 2 left over, and we say 2 over 3, is we take this remainder and we put it over this. That's how we get this fraction. We're going to do the same thing with this. Is we're going to take our remainder here and put it over this right here. So we're going to get 3 over m minus 8. And this right here is going to give us our answer. Okay, let's do number 4. Okay, so we have k squared minus 7k plus 10 divided by k minus 1. So how many times does k go into k squared? We know it goes in or a k. K times k is going to give us k squared. K times negative 1 is going to give us negative 1k. When we subtract that, we're going to get, these are going to cancel out, and we're going to get negative 6k. I'm going to drop this. We're going to get plus 10. Then we know, I want to do it a different color. Negative 6 times our k is going to give us our negative 6k. So that's what we're going to put up on the top. Negative 6 times k is going to give us negative 6k. Negative 6 times negative 1 is going to give us positive 6. When we subtract these, we are going to get, these are going to cancel out, and we are going to get a remainder of 4. So we're going to come back up here, and our answer is going to be 4 over k minus 1. Alrighty, let's move to the next page where they get a little bit more crazy. Okay, let's do 15. So we're gonna set it up as a normal division problem. What times v is going to give us v to the third? I see that it's v squared. V squared times v is going to give us, we're saying v squared times this number right here is going to give us v to the third. And then we multiply this v squared by our 3 also. And that's going to give us 3v squared. Okay. When we subtract that, we're going to get negative 5v squared minus 14v minus 5. Negative 5v times v is going to give us our negative 5v squared. Negative 5v times 3 is going to give us negative 15v. We subtract those, we're going to get v minus 5. Plus 1 is going to give us our 1 times v is v. 1 times 3 is positive 3. When we subtract those cancel out, and we get negative 8. So we're going to have negative 8 over b plus 3. Alrighty. And then let's do 17, and then we'll call it a day. So, one thing real quick with these ones is if you see that these are out of order, see how we go k to the third, and then we go k to the second over here, and then back k to the 1, and then k to the 0th, and then this one we go have k on the second one. So our biggest thing with these is we have to rearrange them in descending order to start, because it's going to get messy if we don't. So we say k to the third minus 4k squared minus 30k minus 18 divided by k plus 30. So then we can do it the same as all the other ones. K squared times k is k to the third. K squared times 3 is going to give us positive 3k squared. When we subtract that, we get negative 7k squared minus 30k minus 18. Negative 7k times k is going to give us negative 7k squared. Negative 7k times 3 is going to give us negative 21k. When we subtract that, we're going to get negative 9k minus 18. We see up here, we can multiply negative 9 times k is going to give us our negative 9k. And negative 9 times 3 is going to give us our negative 27. When we subtract that, we're going to get a remainder of positive 9. No, we're not going to get that remainder. We're going to get a remainder of, positive 9. That is right. So then our remainder is 9 over k plus 3. And I just remembered there was a different example that I wanted to show. Let me see if I can find it. Okay, let's do 11. This should give us it. So when we have, so we see that this is raised to the second power, but then we don't have any value that's anything to the first power. So we need to add in the value. So what I'm saying is to have a placeholder. So when I set up this division problem, I'm going to say x squared plus 0x minus 74 as our placeholder. So however many missing exponents we have, exponential values that we have, we are going to have a placeholder of this 0x or whatever you want to call it. So essentially, if we have x to the third minus 74, then we're going to have x to the third plus 0x squared plus 0x minus 74. So all of these missing descending orders need to be filled with placeholders of 0. I hope that makes sense, but you'll see why when we do it. Then we're going to divide by x minus 8. So x goes into x squared, x times x is x squared, x times negative 8 is negative 8x. So we needed this 0x so that we could add or subtract our x value. So when these subtract, we are adding this, and then we have 74. So now we're good. So then plus 8 times x is going to give us our 8x. 8 times negative 8 is going to give us our negative 64. And when we subtract that, we are going to get a negative 10 value left over. So then we can say that's too many negative signs. We can say negative 10 over x minus 8. And that is going to be your answer. Alrighty. I'm going to just do... let's do this last one. We did this one in class too, so let's do 50k to the third plus 10k squared minus 35k minus 7 divided by, wow, that was an interesting line, divided by 5k minus 4. So 10k squared times 5k is going to give us our 50k to the third. 10k squared times negative 4 is going to give us negative 40k squared. When we subtract that, that disappears. We're saying 10k squared minus a negative 40k, which is squared, which is a plus. So we get 50k squared minus 35k minus 7. Then we see that this goes in positive 10k because 10k times 5k is going to give us our 50k squared. So we're going to get 50k squared down here. 10k times negative 4 is going to give us negative 40k. When we subtract that, we're going to get positive 5k minus 7. 5k goes into 5k one time. 1 times 5k is going to give us 5k. 1 times negative 4 is going to give us negative 4. And when we subtract that, we get negative 3 left over. So we get negative 3 over 5k minus 4. And this on the top is going to be your final answer. All right, I hope that was helpful. If you have any questions, let me know. Here's a little preview of the answers if you want to pause and make sure that you're doing them right. But yeah, let me know if you have any questions, and we can go through more on Tuesday. Or if you need other videos, let me know.